Okay, good go. Where's Bob? There's Bob. So, good morning. Most of you know who I am. Some of you don't know who I am, but you've seen me in the hallway, obviously. I'm Dr. McNally. I'm the chair of the Applied Technologies, which covers all the automotive, HVAC, ECM, line workers. So anything that happens in this building. And this is Mr. Kenny.
Focused just mainly on all the electrical vehicle technology.
Yeah, so Bob is our guru on the EV stuff. The reason we have the combination of students here, we've got our ECM students, we got our line workers, we got automotive, auto body, is because really when we talk about the electric vehicle, it meets in the intersection of what everybody is doing. So those of you who are line workers and you're going out and you're going to be with National Grid or whatever power company, you're going to be responsible for delivering the electricity to the EV charger. All right. Those of you who are studying to be electricians, you're going to be the ones who are going to be installing these things. And there's a lot of jobs out there. This is one of the highest demand jobs out there, is for people to install and service EV charging systems. So there's a lot of money out there. I was at a conference over the weekend and the guy was talking about the green economy and how everybody talks about the green economy. And for some people, that's kind of a turnoff. All right. Not everybody buys into the green economy thing, and that's fine. But what you can do is you can look at it and say, okay, this is the green economy because there's a lot of money to be made here. So, you don't have to love electric vehicles. You don't have to love solar energy. And I'm looking at Mr. Countryman back there. All right. But there's no reason you can't love the money that you make doing this stuff. And the fact that it helps the environment, that's just a benefit for those of us who do think about that stuff. So, and then we get to the automotive side. Obviously, we're going EV. No matter how fast it happens, whether it happens in the next 10 years or the next 20 years, it's going to happen in the span of your career. You're going to be working on electric vehicles. You're going to be working on plug-in hybrid vehicles. So you're going to have to deal with charging systems. So when we look at the intersection between the charging system and going out to the automotive side, going out to the power grid, there's a lot of work out there and a lot of really profitable work where you can go out, you can make that kind of money where, you're not just paying the bills, but you're building generational wealth. So you're putting yourself in that position where you've got that nice house, you've got that boat, you got that snowmobile, all right? Plus, your kids don't have to worry. Your kids are going to be able to go to school. They're going to be able to do whatever they want because you put yourself in a position to be able to earn that kind of money that's going to make your family comfortable for the rest of their lives. Okay? So we're going to get into this, and I'm going to start off. I'm going to talk about the power grid side. And then we're going to turn it over, and Mr. Kenny's going to talk about the automotive side. So I'm going to start back there with our utility poles. So if we come back here, and those of you who are line workers, you'll be able to help me out with this. We've got the utility poles, and I'm an automotive person. All right, so I was corrected. I called them telephone poles, and I've been corrected that no, these are not telephone poles. They are utility poles. So with our utility poles coming in here, what I want you to think about is coming from National Grid. National Grid is generating the electricity, and they're sending it out on the power lines. So we come in here, and we're looking at 13,200 volts coming in. Then we're going to take and we're going to drop that down. Let me ask y'all a question. Where does that electricity come from? And this is a generic question. What's that? Coal? Or how do we use the coal? Okay, and what do we do with that energy? Okay, yeah, and it turns that fan. So we get that rotation. So we take this, we've got that heat energy. We're burning coal, we're burning natural gas, we're using nuclear, and we're generating heat. Now we got to transfer that heat energy into electrical energy. How do we do that? Those of you who had me for electricity, when I say, how do we do something in electricity, How do we typically do it? What's the magic word? Generating the AC voltage through, I heard somebody say it quietly, magnetism. All right, so we got this great big magnet, and we're going to turn that magnet. Now we're burning that coal and we're heating it up, we're generating heat that's going to get that turbine spinning. Once we get that turbine spinning, we got this gigantic magnet that we're spinning. When we take that magnet and we pass it across a coil of wire, what happens in that coil of wire? You're generating that AC voltage, you're inducing it. So that magnetic field that we're all familiar with, all right, we've all played with magnets. If we were sitting here and you had magnets in front of you, not one of you would be listening to a word I'm saying because you'd be playing with the magnets. You know, it'd click together, oh, that's cool. Flip it around and trying to push them together and they won't go. You'd be playing with the magnets because magnets are cool. That force field that you feel from the magnet, it's real. We can take that force field, and when we bring it to a coil of wire, that pressure is literally pushing on the electrons and making them move. Then when the magnet moves away, it pulls the electrons back. So now I got these electrons, they're moving back and forth inside that wire, alternating current. So that's what's happening. They're taking these huge magnets and they're spinning them, and it's generating this high voltage. So we got this 13,200 volts coming in. Now that's a lot of voltage. All right, we need that high voltage to be able to transfer the electricity over a long distance. When we get close to the point where we want to use it, we're going to drop that voltage down. So it comes in here, and we got these big trash cans up here. All right, what are those trash cans? What are they really? Transformers. Okay, so the transformer is going to take that high voltage, is going to bring it down. Okay, so in this case, the way it's set up, we're going to end up with 208 volts coming out. All right, three-phase, 208 volts coming out. So we went from that super high voltage down to a manageable, workable voltage. How does it do that? How do transformers take high voltage and step it down to low voltage? Okay, induction, and that brings us back to magnetism, right? Okay, so we're in here, and we got two coils of wire. We got one coil that's got a lot of windings, another coil that has very few windings. And we're going to take and we're going to induce the voltage through it. So the voltage is coming in. Again, it's AC, so it's moving back and forth. When it moves through the coil of wire, it builds a magnetic field, collapses, builds it, collapses. We can use that to induce into our second set of windings. When we do that, we can drop the voltage down. So now we're coming out of here, we got 208 volts, which for us automotive people, that's a lot of voltage. All right, I spent my entire career dealing with 14 volts. You start talking about 208 volts, we're starting to get scary for me. So that's going to come down, and of course, we got to meter it. Somebody's got to pay for this. All right, so we got the meter we're going to go through. Then we're going to come into what we refer to in the EV charging area as our switch gear. All right, basically it's just a big shut off. So we can take and we can shut the whole system down with one easy switch. Then we're going to come into here, and this is going to be a step up transformer. So we got 208 volts coming in, three-phase. This is going to take and it's going to boost it back up so that we're going to have sufficient voltage for our charger. So this is going to boost it up, and we're going to take it up to about 480 volts. Okay. Those of you who are electricians, I know you're looking at that transformer, and you're looking at this charging station, and you're thinking, that's kind of small. It is. Okay. This is just a stopgap. You know how hard it is to get parts and pieces. We're on a waiting list to get the transformer that's actually big enough. The transformer that's going to be big enough is going to be almost as tall as me and fill up this space because of the amount of power that we're going to have. Then we go through just the standard breaker box, all right, 200 amp. That's going to feed into our DC fast charger. This is the top of the line type of charging. When we're talking about charging, charging that car, we've got 3 different ways we can go. Level 1 charging, just plug it into a 110 outlet. Just for an experiment, I charged my vehicle. I drove it right down to it was like 5%. And then I plugged it into a 110 outlet just to see how long it would take. Day and a half to charge it back up to, that wasn't too bad, but it's a small battery too. So a day and a half to charge it back up to 80%. All right, we avoid going up to 100%. So get up to 80% a day and a half at 110. All right. The next step would be a level 2 charger, which is what you're probably more familiar with. So when you go to the shopping mall, all right, or you go to the grocery store, you'll see a charger similar to this. All right, level 2, this is operating at 240 volts. I have one of these in my house, and this is what I use to charge my vehicle. When my vehicle is down to, typically I get down about 20%, it'll have it back up to 80% in 3 or 4 hours. So significantly faster. So level 1, 110 volts. Level 2, 240. This is a DC fast charger. Some people refer to it as level 3, but the official word for it is a DC fast charger. And this will charge a vehicle like mine in about half an hour, 40 minutes. There are some vehicles out there that'll charge in like 15 minutes. So, you hear people talking about, oh, well, I don't want an EV because it takes forever to charge it. Depending upon the car you have, you might pull into the rest stop on the thruway, plug in, 15 minutes later, you've got your stuff from Chick-fil-A and you're out and you're back in your car and you're driving away. So it's not really a big deal if you can find these. That's where we're at right now. If you can find it and if it's working. Because we need people to install them, we need people to service them. And that's where electricians come into play. And this is also something where automotive technicians, you can work into this industry as well because you have the basic technical skills. So what I want to do is actually open up this charger and just give you an idea of what's going on inside of it. Now, we had arranged to have the line workers turn this off for me, but it looks like they already did, right? They're ahead of the game. Somebody want to step up and explain exactly how you would disconnect this? So if I wanted this entire system shut down, so it's completely de-energized and I can go in there and I can work on it without having to worry about it, how would I do that?
Right now it is disconnected.
Okay.
You'd have to swing those closed to connect the full system.
All right, so I would just reach up here with my hand and just grab that, right?
No, sure.
Yeah, okay. What's going to happen if I do that?
Oh, you're not going to have a good time.
Okay, we're going to need the dust brush to get my ashes up. Yeah. All right.
So what we use is a hot stick. It's generally 6 to 8 feet long. It could get even longer depending on how much voltage there is. But with that, you can either be in your cleats hanging off the pole or in a bucket. And with the hot stick, you'll be standing back, and you can either open or close it. There's simple ones, just like a little boat protector. Typically, use that with the fuses. Be it those off and on.
Okay, so we'll just hook in here. We got that loop. Pull it loose?
Yep.
Okay. All right. Thanks, guys. So obviously, you saw the way I was handling this. This is not hooked up to anything. This is dead. This is never going to be live. We're never going to be dealing with 13,000 volts coming in here. But we've disabled it. So this is one way of shutting it down. So the entire system right now is dead. The other way, going into my switch gear, and that shuts off everything over here. Now, if I had to work on this box, that wouldn't be sufficient. I would want to shut off down here. These are the things that we have to be aware of, but if you think about it, this is common sense. Shut it off at the source. If I'm working on this, I want to shut it off there. If I'm working on this, I'll shut it off here. So we've got this thing shut off. I'm going to open this up. Now I'm going to put on gloves because I've been inside this one before, and I know there are a lot of sharp edges in there. I don't need my high voltage gloves because it's dead. All right, I've verified that. Let's just assume I've gone through, I've tested, I've verified there's no power here. Got my leather gloves on just so that I don't mess up my manicure. You know, I'm administration now. I don't fix cars anymore, right? So we're going to take and we're going to open this up, and this is actually pretty simple. It's just a couple of screws on this one. The hardest part with this one is getting this reel out of the way. Got to muscle it a little bit. Then once that's opened up, we've just got some latches on the side. They're just turn latches. I've taken most of them off. We can open it up and we can see what's going on inside here. This is nothing super sophisticated. When I look at this, you know, we can see we're dealing with some heavy duty power here. We look at the size of those fuses. We look at the size of the connectors on these things. We can see we're dealing with some heavy duty voltage, heavy duty output. I think this one is 72 kilowatts for output. So this is kind of stuff, this will turn you to dust, okay? But looking at the individual components, if you're servicing this, you've got a couple minor components. We've got DC to DC converter. So we need to be able to take and adjust our DC voltage for what the vehicle needs. So we can take and we can change the DC from one level to another. Then we got our AC to DC. We've got AC power coming into this. Going out of it to the vehicle is going to be DC. So we got these components. That's what they're responsible for. This controls the level of DC voltage. These control inverting that AC into DC. For the most part, technicians on this, they would take these out, they'd replace the module in the field, then they send the module back for service. You're not going to open these up out in the field. When you get it back to the shop, that's when you're going to open it up. And it's very easy to disconnect these. They got coolant hoses going through, just a simple squeeze connector, and they come right off. Slide those out of the way, and then we got 2 bolts, and then it slides out. We'll get that later. So I got 2 bolts, 2 coolant hoses. Slide it out. And that's all it is. So you can see the connections for the coolant. We generate a lot of heat here. We got liquid coolant that's going to flow through, take care of that heat dissipation. On the opposite side, we've got our connectors. Very simple. So when you're dealing with these out in the field, that's pretty much the depth that you're going to get into. The main issues that they have with these, when you pull up and you see that the charger is down, number one issue they have is communications. So these things, they're communicating over the internet, Wi-Fi. When they lose communications, it shuts everything down. Typically, technician comes in, resets it, and it works fine. The other thing that they have is the credit card reader. Okay, so this is just like the credit card reader you have at the grocery store, at the gas station. Exact same thing, same issues you would have at the grocery store. You go in there, you put your card in, and it rejects it. Put your card in, rejects it. Put it in a third time, it takes it. You know, so simple stuff like that. So if we look inside here, it's really a pretty simple setup. We got a couple of major modules. We got our communications for the credit card reader. We got a digital display, a touch screen. That's it. Pretty simple stuff. They're paying really good money for us to fix these things. So this is something that you can think about, as an electrician, as an automotive technician. Maybe I want to get into the electric vehicle. Personally, I like them. I love electric vehicles. They're a lot of fun. If you've never driven one, take the opportunity to drive one. They're a lot of fun. But there's also a lot of money to be made for it. And that's really why you're here. All right. Most of you are here because you want to get a career. You want to go out there and, you want to do something that's of value. You want to do something that's a service to your community, but you really want to make a good living. This is an opportunity. So what happens coming out of this? We look at these big cables. When this hooks up to the car, that's where the car takes over. So at this point, this is where I'm going to have Mr. Kenny take over.
Just to piggyback on what he said, for you guys, there is a tremendous opportunity repairing those chargers. I purposely, when I travel around the country, I purposely rent electric vehicles, and I don't do any research on any of the charging availability in the area where I rent the car. It's a national estimated average that 60% of the chargers are out of commission at any given time. I can tell you from my travels, that's pretty accurate. No doubt about it. And 90% of the time, just like he said, the card reader's down, Wi-Fi is down. If Wi-Fi is down, it can't accept your payment. If it can't accept your payment, it's not going to turn on. The second cause of the machine being down is it's been vandalized. The first cause of vandalism is the ends are smashed or the cords are ripped right out of the top of the machine. Why would somebody do that? Money, and they hate EVs. It's the coal guys. It's the coal pushers out the tailpipe. They hate EVs. I'm not here to preach that. He talked about the green initiative. I'm in the middle of that. I do drive an EV just because they're a fantastic vehicle to drive. I'll leave that at that. But most of the vandalism, most of these are damage from vandalism. There's a safety stop on them that if you press that safety stop, say something happens, sparks start flying on the side of the car in the middle of a charge, you can hit the stop just like we have in the shop, shut off the equipment. That cannot just go and be turned back on. They need to call a service technician to be turned that on. They've had cases where somebody has just walked by, hit that just to ha. The machine's been out of commission for 2 weeks. Just because they haven't been able to get a service technician in there to fix it. That is, again, is a tremendous opportunity. You mentioned the cooling inside that charger. Most of the cables are also cooled. If you pick that up later when you get a minute, they're heavy. The next step up from this charger, we're working in megawatt chargers. Megawatt chargers, you're talking thousands of volts and thousands of amps. It's megawatts. But I'm going to talk to you about the car end of it. What happens after it leaves the machine, right? So the vehicle guys kind of get it. What are all the pins on the end of the connector for? If you look at that connector right there, that's our most basic level 1, level 2 connector. If you look at the two big pins on the bottom one and the center one in the bottom, what's that look? Just like your wall outlet. What's coming out of there? AC voltage, just like your wall outlet. If you want to make 120 out of it, we get our hot up here, 120, down here's our ground. Over here, this will switch between neutral and line 2. If we're running 240 through that charger, that'll become line 2. So we can run the same plug to charge AC only. That plug right there charges AC only. When we add that plug to the DC cords, the two big pins on the bottom, we've now made that into a DC charger. The reason we need to retain this connector for that DC charger is that's where our communication happens. That's what I'm going to display to you here today. We have two pins that allow the car to communicate to the charger and the charger to communicate to the car. The first pin is PP, that's proximity pilot. That signal is built in the vehicle. That signal was put in the vehicle for one purpose. Don't drive away with the cord in the car. That's the one. Don't, you see the videos of people driving down the road, the gas nozzle hanging out of the car. You can't do that with electricity. Somebody's going to get hurt. So the number one reason that was put in the car, that's the one that brings up the dash light and says cord connected and won't let you enter ready mode. Remember, these are silent. It's not like you listen for a gas engine to start up. There's no sound. You put it in gear, it won't move. It's not in ready mode. Something went wrong with the proximity pilot signal. The next one we have is our control pilot. Control pilot is exactly what it says it is. It's the control. That's going to regulate the charging. Control pilot signal is built inside of the charger. That comes from here to the vehicle. The vehicle accepts the control pilot signal. When it gets the control pilot signal, it adds another resistor into a circuit, causes the voltage to change on the control pilot. When the voltage changes on the control pilot signal, now the charger has realized that, hey, the car's connected. I'm going to start putting out some voltage. Once the voltage starts coming out of the car recognizes the voltage has left the charger and starts ramping up the controller inside of the car to accept this charge. Now, because it's leaving these plugs as AC, what are all batteries? DC. So what do we have to do to this AC to get it to charge this DC battery? We got to convert it from AC to DC. We're going to invert it in the car. So when we're charging level 1, level 2, this inversion happens inside the vehicle. On the DC charger, that happens inside the charger. So just understand, when we plug into the car, we're looking at AC voltage, just like you plug it in your wall. The only difference between the wall and the car, we add this so we have some safety circuits in there for control. One of the things I get complaints about everybody here is, oh, you're an EV guy, blah, blah, blah. I'm going to get electrocuted if I plug it in. There's no voltage available at the vehicle or the charge end of the charger until these circuits have been completed. The vehicle needs to detect the proximity. At that point in time, though, your connector is connected to the car. One of the biggest failures I see in the field in the automotive side is a poor connection in there. So where does that leave you guys in the electrical industry? You'll be putting connectors on these. And to do that, you got to open up the high voltage units and replace the connectors. They're pretty safe. Again, there's no high voltage there. I'll prove that to you. Until the car talks to the charger and the charger repeats that signal back to the car. We'll go in our protective earth, line 1. Less than a volt, 1300 millivolts. Completely safe to work with that connector. Again, less than a volt on line 2, which would be our 240 connector. Why do I want to know that before I attack this car? Could there ever be voltage on there? Yeah, there's contacting switches inside of there that if one of those ever happened to get stuck closed, yes, you can have high voltage out here at that point in time. So if you're going to go and service the car, verify that's dead before you start working with it. Then you're safe because it will not turn on until you plug the charger in. One other thing we can take note of, that picture doesn't show it well. If you pay attention to this, if you come up and take a look at it later, the two smaller pins in here, the male terminal of that comes from the vehicle is more recessed in the vehicle. Why that is designed like that is so if I remove this connector from the vehicle, those will be the first 2 connectors coming undone. Those are low voltage. We can't get shocked from them. So once that happens and those 2 smaller pins become disconnected from one another, that shuts off both sides of the charging system. It shuts off high voltage. That prevents a spark from flying from my charge handle to the car. That just, so we can't have live spark outside the handle. You can absolutely plug it in the rain. There's no voltage down here until it's plugged into the car. It's safe up here, and they're ground fault protected. You can definitely plug it in the rain. You're not going to get hurt. The one thing I'll tell you, I tell my EV guys this, the one thing you do have to be careful of in the car world is don't leave this plugged into the car and start servicing the high voltage system. For some reason, there's a mechanical disconnect that, hey, I pulled my connection out of the back, the car's disabled, it's all good, but meanwhile, you got 120 volts going into the car. And you fail to disconnect that. So real quick, how these signals work, I'll show you on this lab scope pattern over here. I'm going to show you that there's no voltage coming out of either end of that connector until it sees those signals turn on. Down here in our blue, that's our proximity pilot. That's the signal that's built inside the car. That's the one, don't drive away with the cord plugged in. The red signal up here, if you notice that's around 12 volts, that's built inside the charger. That's just sitting there waiting for something to happen. When it connects to the car, you're going to see the signal change. After the signal begins to change on this red wire, the control pilot, we're going to see some current and some voltage start to occur. Again, that's connected to the charger. We verified the car's dead. No voltage on the high voltage side. I opened up the connector. It's really simple in here. It's got 3 big wires. It's got your L1, L2, your protective earth, 2 resistors in here for the proximity pilot circuit, and a handle switch. The handle switch is so when we go to disconnect it from the car, it releases the mechanical lock. Once we push on that mechanical switch, it will immediately disable the voltage. See if I can walk you through what just happened right there. So if we look at what just happened on the car, right here is where I plugged in the connector. You can see these 2 voltages change. Because proximity pilot, the blue wire, is a 5-volt signal built inside the car, there's no voltage outside for that until I connected the handle to the car. The 5 volts generated in the car went through the handle to my test connector, and I could see that the car is doing what? It's creating that 5-volt signal. The car side is okay at this point in time. Up here, I see my control pilot signal. Notice right here, it drops down a little bit. That drops down because when I plug that connector into the car, we saw it was 12 volts. When we plug it into the car, it latches on to a resistor inside the car. When the latches onto the resistor in the car, that causes this small voltage drop. The small voltage drop tells the charger you just got connected to a car. Get ready to charge. The charger does a couple voltage checks to make sure the car isn't live yet, indicating there's something wrong with the car. Once it's satisfied there's no high voltage in the car, it starts to send out this pulse width modulated signal. That pulse width modulated signal is a signal to the car, hey, go ahead, we're going to get ready to charge if you want to go ahead and turn the charger on. This next dip, we have this pulse width modulated signal. If you look up here, it's around 11 volts. Drops down here down to about 7 volts. That is now the return from the charger to the car. Hey, I got your signal. I saw you're okay. I know you saw my signal here. The car turns on, lowers the voltage in that signal, which indicates to the charger, now go ahead. Now we can start to build high voltage out the end of that connector. The next step, very slowly, it starts to add some high voltage coming out the end of the connector. Here's our AC, right? Household voltage. If I measure that voltage across there on the green, it's about 170 volts. That's the AC going in the car. Why is it so high? It needs a lot to charge a car, but what's coming out of the wall? Should be 120, right? Cogen plant. Are being close to the power supply for the building makes the voltage go up a little bit. So right now, let me ask you a question. If you were looking at this, and we all have wonderful electrical minds in this room, I have my car connected. The car sees the connectors connected to it. That's our don't drive away signal. Our car and charger built this signal and said, hey, go ahead, start charging. We put 120 volts in the car. This is current. Are we charging at this point in time? Not yet. We haven't started to push any current through the circuit yet. Up here is 22 amps. Right now I'm at 0. So I've got voltage. I don't have any current. Can I charge the car without current? No. What do we get when we multiply voltage times current? What's voltage times current? Watts. And watts is watt. Total power. So I don't have any total power going in this car yet because I don't have any wattage yet. It's doing some voltage checks in the wiring right now. All that delay in that time before it starts giving us any current, it's doing some voltage checks. It's saying, let's push some low current voltage. It's high voltage, low current going through the car. It's safe. If something were to happen, it's low current. So before it's going to start ramping up the current to where it could be potentially unsafe, it does some voltage checks, and there we are doing our full charge. Nothing changes in this signal. We still have our 171 volts. Now we're charging at 22 amps. 171 volts times 22 amps is going to give you your full total power output to the car, about 1900 watts, 1.9 kilowatts, maybe a little bit higher. But that's going to give us our voltage out to the car and our total consumption to charge the car. Why do you need to know this? Why does an electrical guy need to know this end of it? A lot of times you'll get called out for a charge fault and there's no code set in the vehicle to determine that it's the vehicle that's at fault, and there's no code set in the charger to determine the charger's at fault. I need to see which one of these two signals didn't happen to determine why the car didn't start to charge. Did I not have my control pilot signal? Did I not have my proximity pilot signal? Or when this started to ramp up the voltage, did the whole thing shut down because it detected that there was a voltage leak somewhere? If it detects there's a voltage leak, it's going to shut off. So is there any questions about that part of it? So I tapped right into the handle that plugs in the car. We read what happens right from the charger to the car. And it's a really safe system. Sure. No, that's I tapped into that with an actual oscilloscope. That's a piece of test equipment. That's a great question, though. They will put a numerical number in there, a text number that tells you what rate it's charging at. The problem with the numerical number that they give you, that what tells you it's charging at, is in wattage. So if it tells me it's charging at 50,000 watts, 50K, is that 400 volts? You know, I don't know. Sure.
You know how they're trying to switch to the Tesla standard? What's
Yes.
the difference between those two?
Awesome question. That is a fantastic question. Here's the deal with Tesla. Every single manufacturer, with the exception of Stellantis, Chrysler products, has adopted Tesla connectors for the next version of their vehicle. So 2025, every vehicle that's built is in the United States is going to have the Tesla connector on it. Why is that different than this connector? Not only is the physical shape different, the wiring inside of it is different. When I told you earlier that we're going to charge DC, we're going to use these two pins and this pin for AC charge only. We use the two little pins for our communication signals, right? We can only charge AC through here. Oh, fantastic. If you'll notice on the Tesla charger, we have the same number of pins. They're shaped pretty similar to this one. The handle's a little bit different shaped, but guess what I can do with this connector that I can't do with this one? DC. How do I get DC out of this, but not this? They changed the 2 AC pins on the top to DC. The car detects that it's been changed to DC. The car then begins to charge to a different module. Not only is the connector smaller, easier to handle, more universal, but guess whose chargers aren't breaking and aren't in that 60% number of the ones that are broken? Tesla has a service for their chargers. Most everybody else does not. The better companies, Livingston does have service people, but there's a lot of companies that do not have service people for their chargers. Just the people aren't available, and it's not something they had the foresight to realize they needed. But the Tesla charger, this small little connector does AC, DC up to 50K watts, 50,000 watts, high voltage DC, high current DC, and their chargers don't break. And there's a fantastic network for them, right? Every place you turn around and look now is a Tesla supercharger. And you can be pretty sure if you pull up to that Tesla supercharger, it's working. You pull up to a different brand charger that's supposed to be high output, there's a good chance it is not working. Real quick story, 2 seconds. I just took another trip over the weekend. I have a car that can accept DC fast charging. Went to my hotel, arrived at the hotel, brand new level 2 chargers there. Probably a dozen of them. Very nice, perfect. None of them are broken or vandalized yet. They're all lit up, ready to work. I grab one of them. You go up to the credit card reader, it tells you to swipe it, says, how do I use this charger? Just like everything else in our lives, we download the app. We put the app on our phone. Once it sees the app on the phone, it says, hey, I recognize by your GPS, you're near one of our chargers. Do you want to use this charger? Yes. Enter your credit card information. Enter your credit card information. Credit card accepted. Go ahead and plug into the car. The one at the hotel I did that to had an $8 session fee. They were charging me $8 to use the charger on top of charging me for the electricity that came out of it. That's like pulling up to the gas pump and saying, hey, you want to use your gas nozzle? I got to get $8 from you first. I was like, what the? Forget it. I don't want to do that. I plugged it in anyways because the battery was really low. I was in New York City away from my house. Plugged that in, let it charge for a little while. Said, I'm going to go find a bigger charger to charge with. Take off down the road. The very first one I find I pull into, back up. There's 3 units there. All 3 are full. Not a person is in their car. Walk around, look at the chargers. 2 of them had completed. 1 has not completed. That is extremely frustrating. That is like pulling up to a gas pump. Somebody's filled their tank and gone in to eat their dinner and left their car there. Unbelievably frustrating. Leave there, go down the next street, look at my maps. It locates another brand charger for me. Pull up to that, says it's got 2 available right now. Awesome. Pull up to that charger. The cords are ripped right out of the top of the charger. Panels are blown off the side of it. I'm like, are you serious? So I pull up to the charger. Can't use that one. Go on my app again, says supercharger. 7 miles from here. Fantastic. I'm running out of mileage. I'm getting nervous. That range anxiety is coming into play. Drive down to that charger. It's a Tesla charger. I don't drive a Tesla, right? So they got these. I got that. It's not going to work. So I look at the app and it says there is CCS available here. Combined charging system. That's DC high output for what is not Tesla. CCS available here. Cool. Which unit are you at? I'm at 1B. That is a CCS unit. No, it's not. Oh, wait, there's more. Follow the instructions on here. Hold in the release button for 2 seconds. Hold the release button in for 2 seconds, push it up in the charge and pull it out. And I have that connector on the end of it now with my 2-pin DC charger. Blown away. Loved it. Magic Dock. Plug that in my car. My car's down to like 11 miles. Battery's pretty dead. It's an 88 kilowatt hour battery. I charged that battery from 11 miles up to 80% charged in 35 minutes. That's what the estimated
So the level 1, I did the experiment with my own vehicle. I drove it till the battery was just about dead. I had like 10 miles left before the battery would be quote unquote empty. And then I plugged it in with my level 1 charger to see how long it was going to take to charge it back up. So I'm going from basically like 5% charge up to 80% charge, which is where we typically want to stop. We typically don't want to go beyond 80%. Okay, kind of like a gas tank. You never completely fill the gas tank because it's going to cause problems. Same basic concept with our batteries. We never want to fully fill them. So to go from 11 miles left of driving range up to 80% charge took me a day and a half. Okay, so it's really long. 110 volts. It's just very, very long process. Obviously, unless you're that person who drives a car, 2 or 3 times a week. All right, you're retired and you drive your car. You go to church on Sunday. You go to bingo on Wednesday. Okay, you can leave your car plugged in for long periods of time. But for most of us, it's not going to work. So in my garage at home, I've got a level 2 charger. All right, I put in the wire, so we're going to be able to run it. It runs on 240 volts. Similar situation, take and charge my vehicle on level 2. Takes about 3 or 4 hours. All right, so that change in the voltage really steps up and improves the charging time. Our big charger over here, we call this a DC fast charger. Some people refer to it as level 3. This is going to be, this particular one will go up to 75 kilowatts, so this will really fill the battery quickly. We get into the superchargers, the high chargers. Bob, what are we looking at for the output for the really high-end chargers?
Right now, 500 volts, 500 amps.
Yeah. So you do the math. Kilowatts, 500 volts, 500 amps. Come on, math majors.
250K.
Yeah, 250,000. So this is going to fill, if I plug my car in and I did the charge on this one, we're looking at about a half an hour to fully charge that car. Okay, so we see the differences. Some vehicles with a charger like this, or we get into the superchargers, you're looking at like 15 minutes to charge your vehicle. So you can literally be driving down the thruway, say, hey, my battery's getting low. I'm going to pull in here. I plug it in. I go in. I use the restroom. I go Chick-fil-A, get my chicken sandwich. I walk out. I unplug, and I'm driving away. I got a full charge. 15 minutes, you're fully charged. So the technology is getting there where it makes it much more convenient to do these things. But they all work on electricity. All right, all this stuff works on electricity. So I'm going to take and I'm going to walk you through going right from National Grid, where they're generating the voltage, bringing us through the power lines, getting into the actual system for the charger. First question for you. Where does electricity come from? How do we generate electricity? Okay. Steam, hydro, movement. Okay. All right. So we've got these different ways of generating movement. All right. With steam, what are we doing with the steam? We're spinning a turbine, right? Okay. Hydro, what are we doing? We're using that water flow to spin a turbine. That turbine is then attached to something else that spins. What's the other side there? Generator. Okay. Big old magnet, right? That's all a generator is, just a big old magnet. If we take, we're going back to your first electricity class here. So, let's step back a couple semesters. If I take a magnet and I pass it next to a coil of wire, what happens in that coil of wire? Induction. We're going to induce voltage. So I got that magnet, and again, it's just a magnet, okay? But magnets are cool. If you think about it, if I came and I said, okay, man, here's a couple of magnets, and I put a couple of magnets in front of each one of you, every single person in here, you're all adults, you're all mature people, you're in school, you're working, everything, you'd be sitting there playing with magnets like a 5-year-old, okay? Clicking it together, flipping apart and trying to push it and feel that floating. You'd all be playing with the magnets because magnets are cool. That force field, When you take those similar poles and you try to push them together, you got a couple of neomagnets, real strong magnets, and you're trying to push them together and you can feel that pressure fighting against you, that force field is real. We can take that force field, that magnetic field, and when we bring it up close to that coil of wire, it'll literally push on those electrons and make those electrons move. Then when the magnet moves away, the electrons go back with it. So the magnet's coming close, we push those electrons, the magnet moves away, the electrons move back. I've got electrons moving back and forth in a wire. What do we call that? AC. All right. Alternating current is moving back and forth. So I've got this big magnet that's spinning and is generating this AC. That's what's happening at National Grid. All right, somewhere they got this big plant, and they're spinning this big magnet, and it's generating this AC. Then they're going to send it out through cables. The first thing they're going to do is they're going to boost it up real high. We're going to get a bunch of voltage. So coming into our utility poles, we're going to be looking at 13,200 volts. Now, for those of us in automotive, when you start talking about thousands of volts, we get a little nervous. All right, I'm used to dealing with 14 volts. 14 volts DC has been my life for 40 years. 13,000 volts coming in. Why do we have to have that kind of voltage? And I'm looking at the ECM mechatronics people. Why do we need that high voltage? Okay, but what's the purpose? Why do we need that high voltage? So we're going to step it up to be able to get it over a long distance. Voltage is pressure, right? Voltage is just our unit of measure for pressure. The higher the voltage, the higher the pressure. So now we can transfer that electricity over long distances. Mr. Kenny's going to have an example of voltage where our voltage is too high here at times, right? Because we're too close to the generation source. So National Grid is generating this voltage. They boost it up really high voltage so they can send it over a long distance. But then when we get close to where we want to use it, we got to step it down. So we've got these trash cans. Okay. What are those trash cans? Transformers. Step down transformers. So when we say step down transformer, what is that literally telling us? Yep, we're bringing that voltage down lower. So I got 13,000 volts coming in. Coming out of this, the way they're arranged, I'm going to have 208 volts, three-phase. So that's a significant drop. Now, anytime we do that, we're going to generate a lot of heat. So if we were to open these things up, these are gutted. These are just empty tubs right now. But if we were to open this up, this would be filled with oil to keep things cool because of the heat that we would generate. So we're knocking that down. We got this down. We got 208 volts coming out of this. We're going to go in. And the first place we're going is a meter because nothing's free. You're going to pay for that. So we got to meter how much electricity is being used so we can keep track of how much to charge the customer. From there, we're going to go into what we refer to in the EV charging as our switch gear. And all it is literally just a switch. All right, so we can turn this on, we can turn it off. If I have to work on this thing, I want to be able to disable it, turn it off. This is one way of doing this. Going into another transformer. This transformer is going to be a step up transformer. So I'm going to take that 208 and I'm going to bring this up, and I'm actually going to step it up to about 480 volts because that's what I need to run my charger. For those of you who have the electrical background, you might be looking at that transformer and looking at the size of that charger and saying, that size difference troubles me. All right, it should. That's not the correct transformer for this setup. It's the one we could get. So we've got on order the correct transformer. The correct transformer for this will actually be almost as tall as me and about this wide square. All right, so it's a significant piece of equipment. It's on 90-day back order like most things. So we come out of our step up transformer. Now we're up to 480 volts, all right, 200 amps. Going in, just a simple switch panel, okay? So we'll have our main lug coming in here, and we can control the voltage coming out. That's going to feed into our DC fast charger. This thing is going to operate at 480 volts, 114 amps coming in. So the AC going in, 480 volts AC, 114 amps maximum. Coming out, when I take and I hook up to the vehicle, this is going to be able to give us anywhere from 150 to 900 volts DC. Okay, so inside here, we've got transformers again. So we're looking at multi-stage transformation here. What I want to do at this point is open this up, give you an idea of what's going on inside here. All right, pretty simple piece of equipment when we get right down to it. Obviously, basic safety stuff. Because I'm working on the charger, I'm going to kill the power at my switchgear. If I had to work on the switchgear, we would go to the utility pole and we break open our fuses here. All right? So I'm just looking at it. What piece of equipment do I want to work on? I'm going to kill the power. This is going to kill the power feeding into my transformer, my fuse breaker box. Obviously, I'm going to confirm that the power is dead. I'm going to go through with my meter, take measurements, make sure it's dead before I put my fingers in there, and then I'm dead. All right, so basic safety there. Then I can open it up, and like I said, it's really a pretty simple piece of equipment. I'm going to put on gloves. I've verified that this thing has no power, so I don't need my high voltage gloves. But I've been inside here before, and I know there are a lot of sharp edges. So I'm going to put on leather gloves just so I don't mess up my manicure. Right. Then I'm going to just take the bolts out of the side. The hardest part about working on this thing is that these cables weigh a ton. Okay, so getting these out of the way and manipulating them is probably the hardest part of doing this. Once I get it open, there's a series of latches on here, which is keys that we take and we turn to release them, and then unlocks, and we can open up the magic door. Everything in here is modularized. So when I go in here and I determine what's wrong, I'm not going to fix any of these individual modules. Out in the field, I'm just going to replace them. So I'm going to replace the module. I take it out, put a new one in, take the module back to the shop, and that's where we're going to do the diagnosis on the module. Figure out, can it be repaired? More importantly, figure out why did it go bad so that we can improve the next generation of them. Simple components in here, stuff that you're familiar with, just packaged a little bit differently. So these two top boxes, these two top modules, DC to DC converters. So we're able to manipulate the proper amount of DC voltage for the vehicle that we're working on. Down on the bottom, we've got AC to DC inverters. So we got AC coming in, but when I plug up to charge that car, I want DC. So I need components that are going to change that AC into DC. So we got inverters. So for this one, we got 2 of each. This is a 75 kilowatt output. If they were going with the 100 kilowatt, you would see that there'd be a third DC to DC converter in there. Looking at the front of this, we've got the touchpad and we've got the credit card reader. When I open it up and I look inside here, the touchpad, those of you up front might not be able to see it. It's like, 6 inches tall, maybe 10 inches wide. Very small component. The credit card reader is even smaller. And again, we don't fix these in the field, we replace them. So if there's a problem, you take the module out, put a new one in, ship it back to the factory for testing. Taking stuff apart is easy. So for this, Bob, can you hold this, please? I disconnected the latch so that it stay open, but now it stays open. So these are all liquid cooled. So there's liquid in here right now. This thing is fully charged, ready to go. If we plugged it in, it would operate. So we got liquid cooling lines. So the first thing I'm going to do is disconnect them. These automatic shut off. When you disconnect it, spring-loaded valves on both sides, so you don't have to worry about leakage. You don't have to worry about air getting in the system. You never have to bleed the system. So just a quick disconnect. I can pull the hoses up out of the way. Then there's just 2 bolts that hold it in place. Then this plugs in by sliding in. You can see on this one, there are 2 connectors up top here. It just slides straight in. So it's very simple. So I just slide it out, then I can pull it out. Right? So when I look at this, you can see this is heavy, but I'm not uncomfortable standing here holding it. We've got the coolant connectors here. If you look inside, you can see the spring-loaded valves keeps it from leaking. On this side, we have our electrical connectors. And again, we don't service these in the field. If there's something wrong, we take it out, we put a new one in, we bring this back to the shop. It gets heavy after a little while. And that's basically it. So any of these modules that we have to replace, we can just very simply replace them. Out in the field, get it in there. The vast majority of issues that you're going to find with these chargers, vandalism, which Mr. Kenny will get into, and then communications. They communicate over Wi-Fi. Wi-Fi goes down just like, your router is going bad at home and your Wi-Fi crashes. You unplug it, leave it unplugged for a minute, plug it back in, it works again. Basically, that's what a lot of the technicians are doing with these things. When they go down, unplug it, plug it back in, reboot it. Questions about anything on this side? Yeah, please.
So as an industry standard, I don't know if these necessarily happen, but as an electrician or a technician, do they have self-diagnostics?
Yes.
Determine what the problem is? So I don't have to troubleshoot to figure out what the problem is.
Okay. Yeah. So if anybody didn't hear, the question was, do they have self-diagnostics built in? Yes, they do. So with the keypad, you as a technician, you would know the combination of buttons to hit to bring it into self-diagnosis. And this is just like anybody who's worked on a car, you use a scanner and it gives you codes and it gives you data, but it doesn't tell you what's wrong with the car. It gives you information. So it's kind of like you go to the doctor checks your pulse, listens to your breathing, takes in all that kind of stuff, and then she's the one who diagnoses you. This will give you the data that you need as a technician to do the diagnosis. But it's pretty straightforward. If you can work on the stuff that we have in this building, the diagnosis on this is easy. Yeah. Other questions? I'm going to step aside, let Mr. Kenny take over and talk about the car side.
Yep, we'll talk to you a little bit about the car side. I'm going to focus mostly today on the level 1 AC charging. Like Dr. McNally said, there's 3 different levels of charging. Our first 2 are going to be AC. So that means that they're entering the car as AC, right? They're alternating current. What are all batteries? They're DC. So we have a problem. How do we charge a DC battery with an AC circuit? We need to have something to convert that AC into DC. We also need to regulate this voltage getting into the car. That one's simple. You plug the gun in, it comes in DC, the DC goes directly into the battery. We just got to regulate the output of the charger. Not a big deal. This one here, we got AC going in. We've got to regulate that and convert it. Now we talk level one. Level one is your standard wall outlet, 120 volts. Just like he stated with his car, that takes forever to charge. The industry will claim, if you figure out all the wattage and do all the mathematic calculations, that you should gain about 5 miles per hour of charge using a level one. So in other words, you can gain 5 more miles of travel distance in 1 hour's time. I'm going to tell you from my experience with my own cars and other ones I've rented, that's incorrect. 1 to 2 miles an hour. So you sit there for an hour and get to go 2 more miles on level one. It's completely useless for a full battery electric vehicle. When you're talking about something like a plug-in hybrid with a much smaller battery, that's fine. You can recharge that small battery in 2-3 hours. A full battery electric vehicle, not good. So we can step it up to level two. Like he stated, most everybody owns a battery electric vehicle. We install one of these at our home. It's 240 volts, right? Doubles the voltage. It also doubles the current. Generally, the max current out of a AC level one charger is going to be around 16 amps. We can double that up to about 60 amps out of that charger, that level two charger. So we take that level two charger, 16 amps, 240 volts, 30 amps, 240 volts. It depends on what the car can accept. So if the car battery is prepared to accept 50 amps at 240 volts, we can charge it 50 amps at 240 volts. Who's good with math? What's 50 times 240? Well, don't make me come up here and do it in my head. My math ain't that good. 12. What is it? 12,000. So that's 12K watts of energy we're putting back in this car, right? To get our watts, we multiply our voltage times our current. That's the total power going back in the car. A typical battery electric vehicle battery, 80,000 watts, 80 kilowatts. So if you're putting 12 back into it, do the math. How long does it take to put 12,000 kilowatts to recharge an 80 kilowatt hour battery if you were to completely deplete it? About 6 hours, right? Somewhere in there. So you can recharge that battery at that rate in about 6 hours. That's not bad. You hook up to one of those, you're going to gain about 5 miles a minute. So every minute you're getting about 5 more miles. That's how much higher the output is. I charged a car 30 minutes and gained about 70,000 watts. It's pretty impressive. So these are the most common level two. Homeowners, you pull up the price chopper, they got all the green spots that everybody loves to park in and block and sends me into orbit because I want to charge my car. And there's a 1978 Ford Granada parked in the spot, right? Can't get in there and charge my car. Guys laugh when he goes in the store. I just gave it to some EV guy. That's what's going to be there. They're going to be level two. Sometimes they're free. Sometimes you got to pay for them. You're just paying for the energy coming out of it. But what I want to describe to you today is the vehicle end, right? How does, when it gets into the grid, it goes in this box or this box, it leaves this box and gets to the car. What has to happen, right, in order to get that voltage to get into the car and the current? When the car is disconnected from the charger, there is no voltage available here. There's no high voltage. That is a myth that many electric people were taught to hate electric vehicles with, right? Everybody in my family knows, hey, he's the electric vehicle instructor. They come up to me and they're like, I buy one of those cars, but I'm going to get electrocuted when I plug it in. Not going to happen. There is no voltage available here, and there is no voltage available here until we have a series of communications that happens, and then we'll turn on the high voltage. And that's not going to happen until we plug this into the car. Now, to turn off the voltage in the car, though, we have to have a switch in the battery, right? So we don't have the voltage leaving the battery when we don't want it to leave the battery. If one of those switches that connects from the high voltage battery to this connector were to get stuck on, yes, you could potentially have high voltage out here. So if I'm going to service this car, I should do what? Pull the service plug. What else should I do? I should verify there's no voltage here,
Su
right?
plan de
So you
fidelización
guys, my high
consiste
voltage
en
people
plan
aren't here. The
cashback.
automotive people aren't here. We're going to use our high voltage gloves. We're going to do a quick test on them every single time before we use them. We're going to roll them up and make sure they hold air. We're going to look at the date on it. We're going to make sure that it's within time. Every 6 months they
Al
need to be
realizar pagos a su
recertified.
cuenta antes de
Unless
la
it's
fecha de
been, they
vencimiento
were just opening
establecida,
them. It's a brand new
estará
pair that you
acumulando
just opened
puntos
and
que
it's got on
serán
the bag of
acreditados a
1
su
year from
cuenta.
the date that you
Dentro de
opened
sus
them.
condiciones está
Get 'em
proceder
certified.
con los pagos en el orden de vencimiento por antigüedad, sin saltarse documentos y después de
High
acumular
voltage gloves.
cierta cantidad de
Remember the other one went? It's all right. We'll work with one hand. Verify that it's no charge in there. So that we're safe to work with it. Bottom pin's going to be your ground. Left pin's high voltage. What do we have there? Less than a volt, right? About 1,000 millivolts. Yeah, nothing that's going to hurt you, right? Go over to the other 2 pin. Nothing there that's going to hurt you. Less than a volt. So we're safe to work on that system. What did I just check on that connector? This is the connector that's on the vehicle. That's our most common J1772 connector. When we add DC charging to the vehicle, if the vehicle has the capability to also DC charge, but it uses this connector, this J1772, when we add DC charging, it becomes a CCS connector, a combined charging system connector. You might say to yourself, well, if I'm going to charge with level DC and I don't need this because it's a different plug, why is this still on there? Because I need these 2 pins for communication even before I DC charge. So how does this one work for AC charging? We're going to have our line 1. That's our 120 volts that comes out of the wall. That's our hot wire, right? That's the black one out of the breaker box. We're going to have a protective earth. And this one over here is going to be in line 2 or neutral. If this becomes line 2, how many volts are we charging with? If this is 120 and this becomes another 120, 240, we'll call it 240. It's 208, 240. There's a variance in there. But that's now what? If I'm using both these pins to charge with, what level did I just step up to? Level 2. This car we're working on today, I have plugged into a 110 outlet over here. We're going to use this pin and this pin to charge this car. But before we can get voltage on this pin and this pin, we have to have something happen on the car. We've got to have a handshake between the car and the charger before that's going to happen. Come on. Give me a second. 10, 23, 20, 13. We're going to have a series of tests done between the car and the charger before it's going to start to charge. Get this up there on the screen for you. Apologize, my computer went to sleep, wiped out my connection to the wireless. Okay. Okay. So those pins that I just showed you on that other picture are line 1, our protective earth, our line 2, and those 2 small pins, PP and CP, proximity pilot and control pilot. Proximity pilot is a low voltage signal that's generated inside the vehicle. This low voltage 5-volt signal is generated inside the vehicle. The intention of the proximity pilot is so that you don't drive away with the cord in the car. That's the signal that the car receives that, hey, I'm plugged in. don't allow ready mode, right? These cars are silent. You don't hear the engine start. When we push the ready button, the ready light does not come on the dash if the plug is plugged in, so we don't drive away with it plugged in. That's the purpose of proximity pilot. Up here, we're going to have this red line. This is our other low voltage. That's 12 volts. That's our control pilot circuit. That's the communication line between the charger and the vehicle to begin to initiate charging. We have our high voltage wire, which right now we have 0 volts on, and we have our high voltage current, which right now we have 0 volts on, or 0 amps on. What's going to happen, we're going to plug this into the car. The proximity pilot is going to apply a set of resistors to that blue line. You're going to see that blue line jump up a little bit. There's a set of resistors inside this handle that the car is going to begin to recognize are now in the circuit in the vehicle. When it sees that 5 volts in the circuit and it adds these resistors, the car now knows the handle's been plugged in. After it realizes the handle has been plugged in, it's going to close a relay that's going to affect the control pilot pin. Control pilot gets generated inside this module. When control pilot gets generated, you're going to see the car do a couple checks. I'll show you, we'll walk through it after we're done. After the control pilot comes on board, it makes another voltage drop. Another voltage drop occurs, then we start to apply the high voltage. The high voltage comes out of the end of the gun, then the current starts to ramp up, and now we're charging the car. Okay. So right now I'm monitoring all of those pins that we're going to use to charge this car on level 1 AC. This is that proximity pilot I told you about. The fact that it went from 0 volts and jumped up to here to around 2 volts tells the car, hey, something just got plugged into me. That 5 volts that's in the car just went from 5 volts down to 2 volts. That when that dropped to 2 volts, the car says, okay, I've got something plugged in. This is coming out of the charger. When this gets attached to the car now adds a resistor to this circuit and causes this circuit to drop down voltage down to around 9 volts. So this circuit, this control pilot starts at 12. When the proximity pilot gets plugged in, the car turns on a relay that drives this down to 9 volts. Once it's down to 9 volts for a couple minutes, they're going to start to do another handshake. They sit there, the car says, okay, I haven't lost proximity pilot. This voltage maintains around 9 volts. This square wave is generated in the charger. That square wave tells the car, hey, I'm plugged in. I'm ready to start charging. Do you want to charge? So the charge unit, the J1772, level 1, has asked the car, do you want to charge, do you want to charge, do you want to charge? The car turns on another set of resistors and again causes the voltage to drop down around 7 volts. When that charge drops down around 7 volts, the car just explained to the charger, I want to charge. Go ahead, turn it on. Let's see what happens. Right after that happens, it starts to flow a little bit of voltage through the car. It turns on our high voltage. Now that plug is hot, right? It's got power in it. I did a quick measurement here. It's about 170 volts. How come it's higher here? Cogen plant, not root mean square. And we're closer to the cogen plant. The voltage is generally a little bit higher here. But I don't have any current going through here. This is a 0 current line. This line up here is about 22 amps. I got a very small amount of current going through this line right now on the high voltage. Why would we turn on the high voltage, but under a very low amount of current? What would be the purpose of doing that? You don't want to spike it. That's a good point, right? So we don't want to blow up a computer by turning on the current like that. The reason they do that is because it sends 120 volts through the car, right? We all have this age-old argument, right? Is it the watts that's going to kill you, or is it the voltage or the current that's going to kill you? You need both. You need voltage and current, right? You can get hurt with 1,000 volts at 1 amp or 1,000 amps at 1 volt, right? At the end of the day, what's 1,000 times 1? 1,000 watts. So 1,000 watts is the total power output. That's what's going to hurt you. So if we have 120 volts with no current, very low current, what's the possibility that next to nothing, we have very low current, very low wattage. There's not enough power there to hurt us. Right now, what that charger's doing, the vehicle is monitoring the 120 volts that's going down this wire all the way back to the battery pack that's under the car. It's saying, hey, if that 120 volts hits the chassis, what am I going to do? Shut off the charger, right? We don't want to get somebody hurt. We don't want to electrocute them. So if there's a wiring problem, it's going to stop the charge. Right here, that's checking for a wiring problem. Very low current, but still are high voltage. After the charger in the car detects that the voltage from here to the charger did not leak, and it sees the high voltage, it then begins to slowly ramp up the current. This control is done inside the charger on the car. It turns this current up, turns the controls on even longer, allows the current to go. Now we have some watts that can charge the battery. You look at that, I had that set right around 21 amps or so. The full total, when it starts to get going, 171 volts, right around 22 amps. That's our full charge right there. What's 171 times 22? Phone calculators. Come on, you guys got them out all day. Right? 171 times 22. 3,762. If we change that into kilowatts, what do we have? 3.8, right? If we round up, 3.8 kilowatts. I have an 88 kilowatt hour battery. How long is it going to take to charge my 88 kilowatt hour battery at 3.8 kilowatts? A while, right? 20 hours. So if it's completely dead and I need to charge it up to the top full, it's going to take me 20 hours at this rate to charge this car. Again, anytime during the charge, if any of these circuits change, that thing stops charging immediately. It monitors the whole time it's charging. So is there any questions on that part of it? How that circuit works? The reason I showed you that is because even if you're a ECM student or automotive student, a lot of the most failures we see at this point in time on electric vehicles are in the charging part, right? So there's a lot of charging faults, either there or here. There's issues. The biggest issue is, you asked about the diagnosis of it earlier. They don't always set trouble codes. So it'll just not charge and you'll not know why it's not charging. You plug it in and you'll never get a charge light on in the car. Why did that happen? Well, now I know what I can check, right? The first thing that has to happen is you have to see that proximity pilot. When the proximity pilot changes, it builds that control pilot. When it builds the control pilot, then it turns on voltage. Which one of those didn't happen? And I can tell you if it was on the charge side or on the vehicle side that's preventing the charge to happen. Piggyback real quick on the inoperative chargers out in the field. I travel around the country. When I do, I purposely rent EVs. When I rent EVs, I do not do research of where I'm going for the availability of chargers. I want to act like a first-time EV renter, right? Get in the car, drive around, go to places and see how many of the chargers are out. The national average guess of inoperative chargers in the United States at any given time is around 60%. So they're saying that about 60% of the chargers do not work when you pull up to them. I will tell you what, that is unbelievably annoying when you drive an EV. Why don't they work? The Wi-Fi is down. It uses the credit card reader, transfers your payment information through Wi-Fi. If it can't transfer your payment information, guess what it doesn't do? It doesn't turn on. The next thing that happens is vandalism. Somebody yanks the cords out of it. Somebody bashes the side of it. the most favorite thing to do, and if you go to almost any price chopper and find their level 2, walk by it, the most favorite thing to do is these are always broken. Always broken. You know why? Guys that hate EVs walk by and go poof and yank them out of the side of the car and bust the end of this off. On purpose. If they don't do that after they yank it out, they will take it like a lasso and smash it on the ground. It happens all the time. There's no reason to hate them. But that's the second most common is vandalism, why they're down. Just a real quick story. Last trip I made down by New York City last weekend, took my EV down there. Pulled up to the hotel. It's got a whole bunch of these level 2 chargers there. Beautiful. Brand new, revamped the facility, put those chargers in. Level 2, there's probably a dozen of them. Great, pull up to it, download the app. It's a charger I never used before. Download the app, enter your credit card information, turn on the charger. There's an $8 session fee. What? Normally it charges me by the amount of energy I'm using, just like my house. This asked for $8 just to plug into my car. I'm like, that's nuts. That's crazy that they want $8 to do that. It's like saying if I went to the gas station and wanted to put the nozzle in my car, they're going to charge me $8 to put the nozzle in my car. I was frustrated, but I needed what? I needed some electrons, man. So I plugged the car in, pay their $8 ransom, start charging the car, spend a couple dollars on charge, get some charge so I can drive to a fast charge, right? I want to fast charge the car so I can drive home tomorrow morning. Pull up a couple apps that tell me where the chargers are and the availability of the chargers, drive to the first one. 3 available units, DC fast charge. 3 cars pulled up to them. I'm like, all right, I'll wait a couple minutes. Get out and look around, not a soul in their car. 2 of them had completed charging. That's seriously frustrating. Compare that to gasoline again. That's like somebody filling up their car, hanging the nozzle up and going in the grocery store and then in the restaurant to eat their dinner and leave their car blocking a gas pump. Unbelievably frustrating. So I said, okay, waited 10 minutes. Nobody shows up. Plug in my phone. Where's the next one? Oh, there's this brand down the street with 2 chargers available. Go ahead, drive down to that one. The cords are yanked out of the top and the thing looks like it got run over by a semi truck. Totally vandalized, 1000%. Things junk, can't turn it on. Fantastic. Pull up the next one, 7 miles from here is a supercharger. Sweet. Pull up to that, it's Tesla. I'm like, you gotta be kidding me. The thing we haven't talked about yet is that Tesla has their own connector. It's really similar to ours, but not quite the same, right? So we have same number of pins, 5 pins. It's shaped a little different. You can't physically plug this into this. You can't plug this into this. So I'm like, fantastic. There's a Tesla charger here. I can't use Tesla in my car. So I open up the Tesla app and it says, hey, this station has CCS available. I'm like, cool. My car's CCS, combined charging system. So it says, what charge are you at? I enter 1B. It says 1B is a CCS charger. I'm like, okay. Nope. No, it's not. Oh, there's instructions. Guys don't read instructions well. Read the instructions. Push the button in. Hold this power button in for 2 seconds, the release button. Push up, pull down, and now it has that connector on the end of it. And I can plug it into my CCS car. That was super cool. It's a Magic Dock by Tesla. That's what's going to replace all of our chargers. Tesla chargers aren't broken. Tesla has a fantastic repair network for their chargers. They need technicians for that. The other fantastic thing about their chargers, I said when we need a DC fast charge with that, we still have that connector, but we put 2 more big DC connectors on the bottom. Looks like a battery cable. Tesla does all of that through here. If they're going to AC charge, they still use these 2 top terminals. They just convert them to DC. Same connector. The car computer realizes that, hey, we're charging DC. Go ahead, start allowing DC in the car. I charged the car, put about 70 kilowatts of energy in it. I had 10% battery left. I want to charge up to 100% in about 30 minutes. Got the thing all charged up. Cost me $26. It wasn't the end of the world. So that's, yes. At the other charger. Yeah, there's no fee at Tesla though, but it was $8 at my hotel. The good thing about the charger at the hotel, I went back that night and said, well, I drove around, I want to top it off. The second time I plugged in, it didn't charge me that ransom. It just charged me the kilowatt hours. So any questions about any of that? Hope you guys got something out of it. Yes.
Do most cars come with level 2s or do they come with level 1s?
So the charger, when you buy the car, most of the time it's going to be level 1. This Leaf happened to come with level 2.
And how much do those cost as a unit alone?
So if you were to buy just this, they're around $500. Plus you got to have it installed. So if you figure $1,500 in a newer house where you don't have to upgrade a panel to install a charger is probably legitimate. They did. It's Tesla. Every manufacturer except Stellantis has agreed to put Tesla charger connectors on their vehicle. I know. You had to get that in there, right? So. Yep. It's not recommended, but yes, you can, as long as you know all the codes and that, but that's what these guys are for.
The codes for installing them, they're updating it. We were having a conversation earlier. So the new code book that's out that's going to be approved, that having an outlet for an electric vehicle charger is part of the code. So you have to, if you're going to do the installation, yes, you got to follow code, have it inspected. But, you know, in this part of New York State, we can do that work. You just have to make sure it's done right. So again, we just wanted to introduce you to some possibilities, some things you might not have thought about as far as career paths, opportunities for you. If you have any other questions about it, you always feel free to stop me, stop Mr. Kenny. We're more than happy to talk about this. We love talking about this stuff. So thank you. I appreciate you taking the time. I appreciate your instructors allowing you the time. So thank you very much.
Thank you.
Did everybody sign in?